Hi Year 7. So today we are going to introduce the idea of distillation to you. Now, distillation is a method of separating mixture of two liquids according to their boiling point. So I have my apparatus set up here and I'm going to talk you through the different parts. First of all, what I want to show you is what we're going to try and separate. So here we have a mixture of ethanol and water. Okay, so we've put some blue dye in here as well so that we know that it is our ethanol and water mixture. So you can see there aren't two layers here, it's all mixed nicely together. So if we're going to separate this according to its boiling point, we're going to need to be able to heat it. So what we're going to do is pour it through my piece of glass right at the top here. This is called a still head, into the flask at the bottom. Now if you notice the shape of the flask at the bottom, we have a look at this. Can we see it's got a round bottom? So we call this a round bottomed flask. And into this as well we're going to put a few grains of things called anti-bumping granules. Now these just provide a bit of a surface. Let me open this up. A bit of a surface for the bumping to occur on, for the boiling to occur on, and prevents too much bumping. So if you watch carefully, you'll see these drop in. There we go. So those are our anti-bumping granules in. So ready for a focus for the boiling to occur on. So my flask is clamped, and at the top of my flask I have what we call a still head, and this allows our vapours that we're going to create as we heat our liquid at the bottom to travel over to the side here. However, at the moment this is open, so our vapours could escape. So we're going to put a thermometer in the top, and that does also mean that we can keep an eye on the boiling point of the temperature of the gases as they come over the top here. So if I take a step back again, so we're going to heat our mixture here. It's going to turn into a gas. The thing that's got the lower boiling point is going to turn into a gas first, and the vapours can then travel up here. We'll be able to check the temperature. Now this is blocked at the top, the vapours then have to travel along our tubing down here. Now this is a great device. This is called a condenser, and a condenser is very clever. If you look closely, you might be able to just make out that there's a glass tube on the inside here, and then a second glass tube around the outside, and this forms like a jacket. So as we go through here, the inner tubing passes all the way through and then comes down this side here. Let me put you straight. And then anything that travels through there is going to end up in our tubes, which are in an ice bath at the end. The jacket around it is connected to two tubes here and there, and if we stand back now we can see where they are going. So there's lots of tubing over there, but we have one of our tubes attached to the tap here. So if we follow this one carefully along, we will see that this goes here. Now I'm going to switch that tap on, and if you look carefully you should be able to see what happens. So did we see there, as I switched the tap on, the water came up here, travelled up here, and then you should have seen it starting to leave at the end. If I zoom in there, you might be able to see it pouring down. And then that second tubing is going to take us all the way back to the sink, so the water is running out of the tap at the end. So what we have here is our tube that links all the way to the outside running through the middle, and now a jacket of cold tap water all the way around. So have a think about what effect this cold jacket is going to have on the hot vapours as they travel along here. So hopefully you've thought that it's going to be cooling them down and turning them then from a gas into a liquid, and then they would just drain down into the end. We've got our ice to keep things nice and cool at the end. So if you look, our test tubes are just sitting in the ice water, and that will collect the liquid that comes off. So what we're now going to do is light our Bunsen burner. We've got a special Bunsen burner for this job. So our baby Bunsen burner that we call a micro burner. Okay, so this is smaller just so we can have a bit more control over our heating. So with our micro burner lit now, I can hold the underneath of this. We can turn it onto a heating flame, a roaring flame there. And then I'm going to carefully heat my mixture. So we've got a mixture of our water and our ethanol. So you might be able to see now that there's some condensation on the side of the flask there. So that's some of our liquid had turned into gas, and then because the top side of the flask is a little bit cooler, it's then condensed again and will run back down the sides. So we can continue heating and heating until we see some boiling going on now. Now at the same time as doing this, I'll also monitor the temperature of the thermometer so we know what temperature the vapours are at the entrance to the condenser and at the top of the flask here. Now the boiling point of ethanol is about 78 degrees, so as we approach that temperature we can then see vapours condensing and at the inlet to the condenser. So we might be able to just about make that out. So we'll keep heating a little bit here, and then we'll monitor the end. You see the condensation around there? You can see movement around the top of the glass like that. And soon we should be able to see some dripping over into our condenser. I can just see one drop coming up at the end, and then we'll see plenty following that shortly. So now if we watch the other end, you can start to see it coming through here. There we go, we could see one running down there. So we'll now, I'll raise this tube up so that we can have a look. And can we see that inside here we have our liquid collected. Now the temperature at the top of the flask is now increasing beyond the known boiling point of the ethanol. So ethanol boils at about 78 degrees. So I'm going to change to an intermediate tube, and then I'm going to carry on heating to bring the temperature up to the boiling point of water. So if we can get our vapours to be the boiling point of water, then what we collect will be that water. We will know that it's the water condensing at 100 degrees back to form the liquid. So that's our intermediate tube gone. Excuse the movement there. And our final tube to collect our water at the end. A slight bit of a flood with a leaking tap there, but we can live with that. So heating again. Let's get it back up to that high temperature. I'll show you right down the end so we can see it dripping away there nicely. There, I'll let you see the leaky apparatus here. So this is our leaky tap. So that's why we've got a bit of a flood on the bench at the same time. Okay, so I think we've collected enough water now of our sample to have a look at, just to prove at the top. So the temperature at the top of our condenser, so remember where the thermometer head there was, is now showing 100 degrees. So we would expect that what is coming over and what we're collecting at the moment is going to be that water, and then show it all at the same time back down to the end. So we were 100 degrees and it's just dripping away nicely there. So we can do a couple of tests to show what we've got here. So the powder I've got on my watch glass here is called anhydrous copper sulfate. Now anhydrous means dry, and when copper sulfate has water around it, it turns blue. So if I take some out of my sample here. So this was our 100-degree sample, and I put some onto the watch glass. Can we see there? We've got that really nice blue colour. Okay, so that is showing that we've got water present. So as I hydrate, add water to my copper sulphate, it goes from white to blue. Okay, now another test we can do. So this time we're going to do the test on the alcohol, is we can show that it will set fire. So we can use alcohols as fuel. So we have our ethanol, so our alcohol is called ethanol here, and we can try and set light to it to show that that's what we've got. So this was my sample that I took first. So that was the one at the lower boiling point, around 78 degrees. So I'm going to put a little bit of it on there, and then I'm going to light my splints. I should use my Bunsen burner really, rather than the cookie one. There we go, baby Bunsen burner doing its job. And then we're going to see if we can light this. So let's bring you guys in and let's have a close look and see what goes on here. Now, I don't know if you can see that. We can see a blue flame around there. Oh, look at that. Can you see the blue colour there? So that is the alcohol burning. Let's do this a second time and see if we can see it even more clearly. So that's the last of our alcohol. That's my flame here. Let's see if I can bring this forward and hold up the paper there. Oh, look at that. Can we see we've got our blue flame? There, we need something white behind it so that it stands out. So ethanol, the alcohol we have, is quite a small molecule and it burns very cleanly, so it's very hard to see the flame. But yeah, it's definitely blue. It's getting smaller and smaller as it's just about all burnt out. You can see it, just a tiny little heap in the middle there.